We will now talk about sets and subsets. So a set is just a collection of objects, and those objects are known as elements. And these can be of lots of different types. They can be titles of books, names of bridges, rational numbers. And a set can contain different elements of different varieties. So we can have a set whose elements are 2, a strawberry, and a monkey. We can describe a set by indicating which elements belong to it. So if the number of elements in the set is small, we can do this by just listing the elements. And we do this by denoting it with curly braces. So curly braces enclose the elements of a set. And we tend to use capital letters. So in this case, we have A is equal to the set of 2, 4, 6, and 10. The order that we list the elements in doesn't matter. So I could also say A is equal to 10, 6, 4, and 2, and it would be the same set. We have this symbol here to indicate an element of the set, and it's read N. So we're saying 2 is in A. And putting a line through it contains that it does not contain that element. So 5 is not in A. Like I said earlier, we'll use capital letters to denote sets. Lowercase letters are usually used for the elements of the sets. And variables can be used to indicate an unspecified member. So for example, if I say little a is in capital A, this means that little a is equal to either 2, 4, 6, or 10. When there are a lot of elements in the set, we may not want to write down the entire list. So we can use these ellipses, which is just a set of 3 dots. And these indicate really long or possibly infinite sequences of numbers. However, the pattern of the sequence has to be clear so that the reader can determine the next elements. So for example, B equal to 1, 3, 5, up to 99, we can see that the pattern is all odd numbers less than 100. If we let C be equal to 3, 6, 9, 12, etc., we can see that this is all the multiples of 3. We can also have a set with no elements, known as the empty set. It's denoted as the 0 with a line through it. We sometimes call this the null set, and we can also just write a set of braces with nothing inside. The empty set has no elements, so for any element A is not in the empty set will always be true. A finite set has a finite number of elements, an infinite set has an infinite number of elements. And we say the cardinality of a finite set is the number of elements, and it's denoted by these bars. We can also say that the cardinality of an infinite set is just infinity. So for example, our set A, which was 2, 4, 6, and 10, the cardinality of A is 4. If I consider the set B, which was all odd numbers less than 100, the cardinality would be 50. And the cardinality of the empty set is 0. We say two sets are equal if they have the same elements. So for instance, we'll define these sets D, E, and F as defined here. We can see that D is equal to E. Their elements are the same. They may not be listed in the same order, but they all are there. However, E and F are not the same, since 6 is in F, but not in E. We also have some common sets that we use so frequently they have their own notation. So Z is the set of all integers. N is the set of all natural numbers, also known as the positive integers. R is the set of all real numbers. And Q is the set of all rational numbers. So this is anything that can be expressed as a fraction. A superscript of a plus sign indicates the positive elements of a particular set. So for instance, R plus is the positive real numbers, Q plus all the positive rational numbers. Z plus is so common that we use N to denote that set, which is known as the natural numbers.